Thanks everybody for coming. Welcome to our seminar, Windows for the Future, Mexico's first certified passive house component. My name's Edward Lowe's. I'm a facade engineer and a component certifier here at Passive House Institute in Darmstadt in Germany. And I will be speaking today together with the chairman of Aventa Windows, Gert Abel. And we don't have a whole lot of time. I know you're all probably on your lunch breaks, so we'll just get straight into it. So why does passive house component certification matter? Well, low energy buildings are of course a vital part of addressing not only the climate crisis but also socioeconomic issues in terms of lifting people out of fuel poverty and creating a better planet for future generations. And the Passive House and Enefit standards are among the strictest energy standards for buildings in the world, so they're a great way to make low energy buildings. And an important part of being able to build to the Passive House standard is the local availability of Passive House standard construction components, such as highly insulated construction systems or high efficiency heat recovery ventilation systems, and of course, high performance windows. We can't achieve cost efficiency if we need to import these components from overseas. So that's why it's so vital that companies like Aventa choose to certify their components so that designers in the region know that there are products of sufficient quality available on the local market. So how does component certification work? Well, for Windows, it's quite straightforward. The manufacturer sends us their designs, which for Windows consists of CAD drawings and material thermal performance information. We then perform our evaluations, which for Windows is generally software simulations using finite element method thermal simulation software. And if the applicable criteria are met, then the product can be certified. If they're not quite met, then we can provide consulting on how the design can be thermally improved. And manufacturers who certify their components are then able to market their products with our component logo, for example, on their website or in their printed literature. And for Windows, this looks like this. They get this logo. So on the right, you can see also written at the top, you have the climate region that the product was certified for, and this goes from Arctic to very hot. And then in the middle there, we have the efficiency class. So this is specific to Windows, and we'll go into a bit more detail about that later on. But essentially, this is intended to encourage the development of kind of slim windows that are also thermally very insulating and that allow for increased areas of glazing to optimize solar gains and daylighting. And the climate regions are distributed across the globe like this. And you can see that for each region, there is a specific UW value. This is the heat transfer coefficient of the window, a U value that's required. So for the cool temperate climates like Germany, where I am, this is 0.8 watts per square meters Kelvin. One climate zone warmer, the warm temperate climate, we go up to 1 watts per square meter Kelvin. And then for warm and hot climates like in the south of the US and in Mexico, it's 1.2. And we'll look at what this means and how this is calculated a bit later on. And what about the climate zone distribution around the Gulf of Mexico? Well, you can see here on the Gulf Coast of the USA, we have a hot region in Florida, and then warm going along the kind of the northern Gulf Coast, and then getting hot again in the south of Texas. And then as we get into Mexico, we can see we're getting into very hot territory at the coast, but then actually once you get up into the kind of higher, up on the plateau in central Mexico, where Mexico City and San Miguel de Allende are located, it's a little bit cooler, so warm and hot once again, and then around onto the Yucatan Peninsula, we're back to very hot. And we'll see what that equates to in terms of window design shortly. But first of all, what's not included in the criteria for components, but should certainly be borne in mind for those designing to the Passive House standard in these kind of hot and humid climate zones, it's really essential to consider both shading and solar protection glazing. Overheating of interior spaces is absolutely something we need to avoid. We also want to reduce our space cooling demand. This is even a problem here in Germany in the summertime. And the best way to do that is to add shading devices like external blinds. Like this is a certified system from a German manufacturer here called Warmer. together with glazing with a low G value or low solar heat gain coefficient. So this might take the form of something like a reflective film on the outside of the glazing. And in the whole context of the building, this will reduce the cooling demand as far as possible, and then, of course, ensure occupant comfort. And what about the window frames themselves? Well, we'll start with our newly certified window from Aventa. This is the Ventana Termoacustica. Excuse my pronunciation. I'm sure you'll pronounce it properly later on. So this is what the window looks like in section. So we can see it's made of two routed wood profiles with the glazing bar to the inside. We're using silicon sealed low emissivity double glazing with a warm edge plastic spacer at the edge. Normally in kind of conventional buildings this is made out of metal, but in passive house construction this needs to be plastic, it's less conductive. We can see the window is double sealed. I think we're using synthetic rubber gaskets, so we know that it's going to perform highly also in terms of weather and also air tightness. This is an example of another warm/hot climate window. This time it's from a manufacturer called Calco in India. And this is a thermally broken aluminium frame. So we can see our aluminium profiles connected together with these are glass fiber reinforced plastic sections and polyurethane foam insulation in between. Again, low emissivity double glazing with a warm edge spacer. And then this is how a warm/hot climate zone window looks like in PVC or vinyl. This is from a Turkish manufacturer called Firatpen. So you can see we've got our extruded plastic profiles, and these have like a lot of little chambers inside. So the chambers actually kind of mitigate the need for actual insulation material inside the frame. So we don't need that here. And then here in the middle we have these are folded steel reinforcements. In some windows, in more kind of strict climate zones, these might be made from glass fiber reinforced plastic, but for warm and hot, it's absolutely fine to use steel. And then again, we have our low E double glazing with a warm edge spacer. If we go to the very hot climate, we can see how the design of the window changes quite significantly. So this is our only example of a very hot certified window on our database. And this is from the UAE branch of a Greek manufacturer called Alamil. And we can see how much thicker the frame gets and how much taller. And it has much wider thermal separators, and you can see there's quite a lot of insulation in the cavities there. In this case, the insulation is made from aerogel, but actually it doesn't need to be made from aerogel. It could be made from a more basic insulation like EPS or polyurethane, and they still would have met the certification standard, but I think they wanted to develop kind of like a concept window here. But then probably most notable is that we've gone from low E double glazing to low E triple glazing, because once we're in the very hot climate zone, the U value requirement actually gets more strict in comparison to the warm and hot climate zones, because we're much more concerned with keeping heat out of the building and reducing our cooling demand and keeping the interior comfortable. So let's take a quick look at Aventa's certificate. The format is more or less the same for all certified transparent components, so just the color scheme changes, and you can see the map there where the kind of applicable climate regions are on the globe. And we can see here the criteria that needed to be met for certification. So a UW value of 1.2 watts per square meters Kelvin, UW installed value of 1.25. So we have this slight additional allowance to account for the installation thermal bridges of the window. And we can see we used a reference UG value, the heat transfer coefficient of the glazing. Here we used 1.1. And then at the bottom, you can see this is the temperature factor that needed to be met. So this is to do with the coldest point of the interior surface. Then that means that on cold days, and actually I read that in San Miguel de Allende, it got down to -10 at one point. So we need to make sure that on colder days like this, there's going to be no risk of condensation or mold growth over time. Yeah. Then inside the certificate, we can see we get a product description and an explanation of the certification. We also get this handy table, which shows us what the UW value will be when we use different glazing UG values. And then following that, we can see how the window performs when installed in 3 different passive house standard wall types. Here we used specifically a concrete wall with an EIFS system, a concrete formwork wall, and also lightweight timber construction. And if we look at the first example, we can see here the detail of the wall buildup and how the window should be positioned within the wall. And for EIFS, usually it's the window, well, in this case, we can see it's sitting in the concrete layer. For colder climates, it might be shifted out into the insulation layer because it performs better that way. But in any case, you can see that at the top of the window, and this would be the same detail also at the sides, that the window is covered to the outside with insulation. This is kind of a hallmark passive house construction type detail. And then you can see at the bottom, we've got our installation thermal bridges. A couple of those are negative, which are then contributing to achieving this 1.24 watts per square meters Kelvin UW install value. We need it to be under 1.25, so this is a certifiable value. And we'll take a quick look at how these values are calculated, and then I will hand over to Gert. So we follow the ISO standard 10077 part 1 for this. So it's a reference size of 1.23 by 1.48 meters. We take the area of the glazing, the area of the frame, the length of the glazing edge, and then the length of the installation. And we plug all of those into this formula. So it is the U value of the glazing multiplied by the area of the glazing plus the U value of the frame multiplied by the area of the frame plus the psi value, the linear heat loss coefficient of the glazing edge multiplied by the length plus the, and this is something that is not in ISO 10077 part 1, it's something that we add because we believe it to be important. It's this arrow here. This is the thermal bridge at the point of installation between the window, the frame, and the external wall. And this all divided by the area of the window, AG plus AF, will give us our UW installed value, which is what we're then comparing against the criteria for certification. And then from our UF and psi G values that we got from our thermal modeling, I'm aware this looks very dense, but essentially what it means is that we can take those values and we can calculate our psi opaque, which is our way of kind of ranking window frames in terms of the balance between the opaque part and the glazing. So essentially, in this case, the lower the area and the lower the U value of the frame, the lower the linear heat loss coefficient of the glazing edge bond, the lower our psi opaque value, which is what we have in our table here. And this equates then to our passive house efficiency class from PHC to PHA+. So essentially, the skinnier and the better performing the frame thermally, the better the efficiency class. I should say, however, that the vast majority of components are either PHC or PHB efficiency class in our database. It's actually PHA and PHA plus are kind of the outliers. But yeah, this is how our system works. Okay, so that's all from me. Thank you everybody for listening, and I will hand over to Gert from Aventa Windows.
Okay, great, Edward. Thank you very much. I think it's even I'm a little bit in Windows, but it's mind-boggling to follow your presentation, and you have to digest that. But it's on the other hand, I think it's very impressive what passive house. I think you are, what do you have? 30 years of existence, or 35? What you have developed in this time frame, and that we really have some hard facts, and that you can back up proper design for different areas in the world, for different climate zones. And I think it's a big step forward, and I was always impressed by your institute or what you have achieved over the last 30, 40 years. With this, let me, I'm taking a little bit more 10,000 feet view of the subject, and a little bit opposite of yours. You know all the details at a very high scientific level. So let me do it a little bit more in general terms. So I would like to say here, the last 3 or 4 decades. So this ideas of a passive house and using less energy, especially for our living spaces, has been now around maybe for 40, 50 years, but it has accelerated in this time. And it is really a very this push here has been very interesting, what has happened in this time period. And so I think we all really have gained a lot in those last 40 years by the developing of a global economy. And we all have benefited from the economies of scale, which the global economy has provided for all of us. And I think this is really comparable, and it was so fast. What was developed then over the last 10,000 years, the last 10 centuries, there we had two big development for the human race. One was clearly, I think, the advancement of agriculture, of agricultural production, which has allowed us today, it's kind of unbelievable, that we can feed 8 billion people in the world. And this, of course, has it's not the case that all 8 billion people have enough to eat, but it is really the production is there, and we even have clearly an overproduction. And so we have the first time really on big scale the problem of obesity of human beings. But we still have some areas where people don't have enough to eat. But this is not a question that we don't produce enough. I think it's a question of lack of proper distribution. And so it's very, very also, if we take a look at this, incredible what has happened during this time period. I think the second very important development was more the last 200 years was the development of production of goods, both industrial goods and consumer goods, so that even today we can speak of an overproduction of goods. We have whatever you want to buy, you have 50 different models you can buy from and compare that. So it is also a very extreme development which has happened over the last 200 years. But there's a negative side to that we really have done this. The result was that we are misusing our natural resources, and we have used the environment, and we are seeing now the effects of this of the last 200 years of this developed industrial age which we are going through. And there, I think it makes sense that we start to think a little bit in a different way, especially with the way Passive House has brought us forward, the way we think about using our resources which we have. And so the idea, I think you all know, Passive House really means that we are negative in using energy for our housing, but we even produce more energy with our housing than we use. And now we are coming to the point here of our presentation here today, regionalized production. I think this fits very well in this overall theme. At the moment, we are with globalization, we are sending all the products around the world all the time. And it is questionable if we really pay enough for these products, because most of the time the cost for distribution is not probably completely covered in the cost which we pay for those products. And this brings me now to Aventa, why Aventa exists and what we are trying, how we are hoping to contribute to reduce the problems we are seeing over the last 20, 30 years. And so this was a small little company, very typical for Mexico. You have many, many carpentry shops. Most of them are small little shops with 5, 6 people working there, maybe an owner or a master carpenter. And then you have some bigger ones. And the company before Aventa, which was called Atrojo, was a typical company, and they would build furniture to the design for new houses. There was an architect there, he would design the furniture. And then he asked several suppliers to build these furnitures. And that's what Atrojo, or the predecessor of Aventa, used to do. But and I got involved a little bit because I was living in Mexico for 20, 25 years in San Miguel de Allende, and we became friends with the owner. And so we decided we looked at that, but it was always difficult to do this project business, building furniture for single projects. And so the idea came up because people, they were asking us architects if we have better windows. So we looked at the European window technology and traveled through Europe several times and found that there's really a highly advanced technology of windows which are very well insulated and also have very good thermal acoustical effects, especially in big cities where you have a lot of noise. This can be an important part of building correct windows. And here the ideas of passive house really coincided with the ideas what we wanted to offer here in Mexico as windows in the future. Most of this technology was developed in Austria, Switzerland, and southern Germany, and still is, and most of the development happens there. And so we decided to go into this business. Over the last 2 or 3 years, we bought some machinery over there, and now we are doing the big step. We are building a brand new factory, completely made out of built in wood and not in concrete and not in steel. And we are buying high-end machinery to really automate the process and secure very high quality by buying CNC machinery and by improving the process, how to make the best windows, hopefully comparable with the best windows which you can find in Europe and maybe in the US. And but now this is not easy to become a certified component manufacturer. And we were very lucky and that we got in contact here in Mexico with a passive house, and we had one of our first windows which we made certified by passive house, and this has opened our eyes where we have to go. So we will at the moment we are only offering one type of profile. We will offer 4 different type of profiles, and this will give us the chance to really meet the needs of the customers, to meet also the requirements of passive house. And then you have to do regionalized production isn't easy either, because you still have you need customers who want to buy your products. And most of them at the beginning, there are some good reasons why they are hesitant to do that, because they don't believe that you can really produce the quality which you can maybe buy from in Europe or in the States or in Canada. And so their passive house really helps, because now we are certified, so we can prove that we can really do the same quality. And just telling customers this story is very often not good enough, because how can they know that we are just not promoting our products, but they really are able to really create products which are up to snuff and can live up to global standards. So it really forces, I think, the companies like us to improve their quality, and it also gives us a lot of credibility in our customer base. And of course, the other advantage is you don't have to transport windows from Europe to build good houses in Mexico. And so we are reducing the impact, the negative impact, I think, of the global economy by producing locally. And of course, you have other positive effects. We can employ people who are well trained and who we can really offer attractive job possibilities to people in Mexico as well. And we need people who are well trained and really know on engineering level, know what they are doing and can help develop this further. And yeah, these are my basic ideas. As mentioned before, we will offer profiles of 70, 80, 90, 100. And we will also offer different material combinations. Our major product, of course, is wood. And there we have the advantage that you have a lot of different woods available in Mexico. We bring in very often fir, which is Canadian fir, Douglas fir, or we use some other softwoods if we want to really improve or maximize the insulation values. On the other hand, you have some very good hard tropical woods available in Mexico. These are especially used closer to the coast, where the question of durability is more important, and we have been very successful there with a big project now on the Pacific coast for a new hotel there, where we used hardwood, tropical hardwood. And so we really have the chance here to offer everything which is required. We will work now with the new factory and our new profiles over the next 6 months very closely with Passive House to have all these products properly certified. So I wanted to finish with the idea again that we are trying to really create products which are very conscientious about the environment. Of course, wood by definition is a recyclable product. And I would like to say at the end, soft power is very often superior to hard power, or in other words, mind over matter. Thanks for the time. Thanks for including us and giving us that chance to talk a little bit about Aventa.